I shipped infrastructure I couldn't have built before. So full stack deploys, self-hosted authentication, a 10 container production stack running for a real client. And every time something broke, the problem wasn't the AI, it was me. I was imprecise 3 prompts ago. And that's the part nobody is writing about yet. Most of the writing about AI right now stops at the headline, that AI made development faster. And it matters, but the second order effect is the one that's been eating my last 4 weeks. Just like with artisanal coding, AI coding requires discipline. The discipline doesn't disappear when AI removes development friction. And by friction, I mean all the typing, the file-by-file edits, the compile loops, the way old code bases used to punish sloppy thinking. That friction is gone now, so the discipline has to come from somewhere else deliberately. And when it doesn't, the failure modes, the ways the software can fail, don't surface in the code. They surface in you, and then they surface in the work. And by the time you see them, you're already 3 steps deep into a problem that didn't have to exist. Which I want to admit feels stupid to say out loud, because it's the kind of thing that should be pretty obvious. AI is a tool, you're holding it, of course the problems are downstream of how you use it. But the texture of how that failure happens has changed. The mistake you make at hour 1 shows up at hour 4, in a part of the system you weren't paying attention to. After the model has confidently built 3 layers on top of an assumption you never actually agreed to. You just let it happen. And most people building with AI right now haven't caught up to that, at least not yet. I'm calling it the friction discipline substitution. And I think it's the single most important thing I've learned this year about working with AI. The next 3 patterns are what that failure actually looks like. So it's 3 projects and 3 lessons that I keep relearning, because when you're deep in the trenches, the trap is invisible. And the first one came together for me as a physics analogy. AI development now is more like physics than like coding. The faster and bigger something is moving, the harder it is for it to change course. That's the inertia principle in mechanics, and it's also what's happening every time I open an AI session and let the context build up. Every instruction I give, every file I let it read, every correction I issue without slowing down to be exact, all of that becomes mass, and mass has momentum. By the time I notice the work is heading somewhere I didn't actually want, the cost of changing direction, of moving that mass, has compounded into something I can't pay in the same session. Let me give you a specific example, because the abstract version of this is the kind of thing you nod at and never use. 2 weeks ago, I was 4 hours into a marathon vibe coding session in Claude Code for a client platform. 10 containers going up at once, so self-hosted Keycloak, OSRM, Photon, the whole stack. And somewhere around hour 4, I caught myself drifting. The session had built up a few hundred messages of context, and I'd been fixing things downstream without going back to refresh the working model, the core assumptions upstream. The AI was helpful and patient, and confidently wrong about an architectural decision I hadn't actually agreed to, but hadn't pushed back on either, because I was tired and because the work felt like it was almost done. The right move was to start a new session, strip the context back, and re-evaluate the architecture from scratch before asking the next question, giving the next prompt. And I almost didn't do it, because the inertia of the current session, all the work that had piled up, all the time I'd invested in building that context, felt like it argued for pushing through. I felt like I was so close, and restarting felt like throwing away progress. But that feeling is exactly the trap. The progress isn't the context. The progress is the running system. And quickly rebuilding the context is one of the things AI is actually great at. It's often the cheapest path forward, even when it doesn't feel like it. So the bigger the context, the harder it is to shift direction. So the discipline turns out to be precise early, not fix imprecision later. The old friction used to enforce that, because every line you typed manually was a moment of forced clarity where you had to make an active decision. AI removes that friction, so that clarity has to come from somewhere else. And here's the part that's a little bit embarrassing to admit. What replaces the friction isn't clarity by default. It's whatever else fills the gap. And in my case, the gap kept getting filled by multitasking. The context mass I just described didn't appear on its own. I built it by asking AI about 3 things at once. Because the cost of switching projects used to be obvious. You'd close one editor and open another, reload the project context, find your place in the code base, and get the build running again. And by the time you've done all that, you've already paid in time and attention. So you'd resist switching, and you'd batch your work into clean blocks. AI removes most of that overhead. The next prompt is just the next prompt, regardless of which project it's for. So the visible cost, the friction of context switching that used to make you stop and think, is gone. But the actual cost was never the overhead. The actual cost is the imprecision that comes from divided attention. I noticed it most clearly in week 2 when I was running 3 things in parallel. A coverage tool for one client, a platform build for another, and the Afterwork analytics work in between. Each of them was fine to ask AI about individually, but asking about all 3 in the same morning with the same depleted attention produced different output than if I'd given any one of them a clean 2-hour block. The output wasn't catastrophically bad, it was imprecisely good. Working, but a patchwork of decisions that weren't entirely mine. Close enough to look right, structurally aligned, but missing the specific constraints I would have specified if I'd been fully on it. Which is exactly the kind of imprecision that builds up as session mass and costs more later. And the part that really gets to me is that I knew this already. I spent a lot of time thinking and writing about constructive capacity, which is basically what you can actually pull off in a day is your raw mental engine times the scaffold you've built around it times the willpower you have to spend that day. And willpower depletes faster when you context switch. I know this. I've made the argument in scripts and voice logs, and I still did it because the ability to multitask with AI feels free at the moment you're doing it. The costs only show up later in places that are harder to attribute back to the original decision. So if there's one operational rule I've started keeping out of these 4 weeks, is that AI doesn't change the scarcity of attention. It just hides the cost of spending it sloppily. There's a third pattern though, and it doesn't depend on either of the ones we've mentioned before. Even if you're precise and single-threaded, AI introduces a new failure mode that only surfaces after you think the build is done. But before I get into it, if you're finding this interesting, give this video a like. It helps more people see it. Going back to what I was saying, the third failure mode, the one that only shows up after you think you're done. The bugs aren't where you looked. They're in everything that wasn't important enough to look at. This one took me 2 projects to see clearly, and even then I'm not sure I would have named it as a pattern if I hadn't sat down to write all of this out. The pattern itself isn't new. Anyone who's shipped software for long enough has had a bug live in the surface they weren't thinking about. The auxiliary thing that build needed but that nobody was paying attention to. What's new with AI is the scale of that surface. The model produces complete looking outputs for everything around what you actually ask for. And the parts you barely ask for are exactly the parts you won't think to check. So the same failure mode that used to be a footnote in normal development is now a dominant one. The first time I really felt this was on a dashboard built for a client, a school breakfast voucher management system with features such as transaction validator, a reviewer flow, and an audit log. It's the kind of thing where you cannot afford to ship a bug because real money and real compliance are on the line. So that's where the rigor went. Hours of testing the audit trail and edge cases on the validator. And the audit logic works. It's solid and we caught the issues we cared about catching. But the expert button doesn't work properly. The filters don't filter properly either. There are pieces of the UI that look right and behave wrong, and the only reason we know is because the actual users started running into them. They aren't the initial visual thing you'd look at, and they're not part of the high-stakes flow. They're the auxiliary services the build produced because we asked the AI for a complete dashboard. And a complete dashboard typically has those UI elements. The AI built them and they look finished. The second time was the platform build I mentioned earlier. We shipped it on April 22nd, and for 8 days it ran. Real traffic, real users, no visible errors, no signals from monitoring that anything was wrong. Then on day 9, a routine maintenance update pulled in a newer version of one of the containers. And the newer version couldn't read a file the old version had saved 8 days earlier. It's the kind of bug that hides deep inside how the engine stores its state, in a layer no normal test would ever touch. And the container went straight into a restart loop, 9 restarts in a row with the CPU pegged. And the system that had been fine for over a week was suddenly not fine anymore, in a way that no amount of testing the visible application surfaces would have caught. The user found it, not me. A user took a screenshot of the dashboard showing the restart looping container and sent it to me. And that's how I learned that the system I'd built had a latent bug in a layer I never thought to look at. Sitting there for 8 days, waiting for the routine maintenance pull that would expose it. The principle I wrote down after that one is short. When state is bound to a version, the version cannot float. So pin the image and don't let latest retag itself into your production stack. It's a small operational rule, but it sits inside a much bigger pattern. The dashboard's broken filters and the platform's broken upgrade. Two different layers, same mechanism. With AI building, every surface looks finished. The transaction invalidator looks finished and is finished. The export button looks finished but isn't. And the 8-day-old container looks finished and is until the version floats. The AI output passes the look and finish test by default because it's been trained to produce things that look finished. So the bugs survive in whichever layer you weren't actively looking at. This is the part I keep underestimating. Each time I assume the place I focused on is where the work needed to happen. And each time the cost lives somewhere else. So that's why if you take any of this seriously, 3 things actually have to change about how you work with AI. The first is that multitasking with AI feels free, but it isn't. Treat it the same way you would treat multitasking before AI, as a tax paid in imprecision, even if the friction no longer makes you feel it in the moment. The second is that imprecise early guidance and prompting tends to compound. The cost is paid in session mass, not in any one bad decision. So pay the precision now or pay the rework later. And sometimes the cheapest move is just starting a new session. The third is that bug testing has always been a deliberate action, but the organic process of building used to filter most of the surface level stuff out for you. With AI building, the filter is gone. So you have to walk every layer that isn't the main feature on purpose. Because what slow building used to expose for free, every surface as you build it now has to be scheduled. So the capability ceiling moved, and most of the writing about AI is still about that. What's now possible and what's now buildable, and it's worth writing about. But the floor of what you have to do deliberately moved with it. The discipline didn't disappear when the friction did. When the typing and the compile errors and the slow loops all went away. It just stopped being automatic. Friction was discipline by accident. Now it has to be discipline on purpose. So I'm curious, when's the last time AI built you something that looked finished but wasn't? What was hiding in the layer you didn't think to check? Drop it in the comments because the best answers might become a future video. And if you want to see where this physics frame actually started, when context first became the thing I was managing instead of the code, I broke that down in my episode on context engineering right here. That's the whole foundation of this video. Subscribe, this is Afterwork.